Imagine stepping into a quiet pod on the equator, pressing a button, and riding straight up a ribbon thinner than your arm. All the way to space. No roar of rockets. No fiery death plume. Just smooth, electric, boring as hell progress at a couple hundred miles an hour until you're looking down at the entire planet like it's a giant blue marble. That's not sci-fi anymore. That's the space elevator. And yeah, it sounds completely insane, until you realize it's probably the smartest dumb idea humanity could build right now. Here's the crazy part. We're closer than you think. The materials exist. The physics check out. The only thing missing is someone with the balls and the systems thinking to actually make it happen. Let me walk you through how this thing would actually get built, because once you see the system, you can't unsee how it changes everything. First, forget every cartoon tower you've ever seen. This isn't a building pushing up from the ground. That would snap like dry spaghetti. Instead, you start in space. You go to geostationary orbit, 22,000 miles up, where the cable wants to just hover there thanks to Earth's spin. You drop one end down toward the planet while you extend the other end out as a counterweight. Tidal forces and centrifugal spin keep the whole thing stretched tight like a guitar string from hell. But the real plan is way more elegant. You don't need some fantasy unobtainium. We have 3 materials right now that are strong enough in theory: carbon nanotubes, single crystal graphene, and hexagonal boron nitride. The secret sauce isn't raw strength, it's specific strength. How much load it can carry per unit of weight. These bad boys crush it. The smart way, according to the serious papers, is the seeding approach. Launch a super thin seed cable first, like a single hair weighing just 20 tons total. You get that thing anchored on Earth, probably on a floating platform out in the ocean near the equator to avoid lawsuits and airplanes. Then robotic climbers crawl up that seed cable, laying down more and more material, thickening it like a suspension bridge built in reverse. Each trip makes it stronger. Exponential growth. Systems thinking at its finest. Where you go full asteroid route. Grab a carbonaceous space rock with the right chemistry, process it in orbit into nanotubes or graphene sheets, and spool out your tether while lowering it down. One end kisses Earth, the other end has a massive counterweight keeping tension. Now the fun, engineering fun. The tether isn't uniform. In the constant stress model, it changes shape with altitude, thicker where the forces are highest. Climbers moving at 200 to 300 kilometers per hour create Coriolis forces that make the tether sway, but you just time multiple climbers to dampen the oscillations. Power. Ground-based lasers beaming energy up to the climbers. No giant batteries. Drive system. Either friction wheels gripping the tether or electromagnetic if the material conducts. You put small stations at LEO and GEO for transfers, refueling. We're just chilling with a view. First climbers haul 5 to 20 tons. Later ones haul 100. Multiple elevators along the equator, and suddenly you're moving millions of tons to space per year instead of the pathetic thousands we do with rockets today. Cost to orbit drops from thousands of dollars per pound to basically nothing. Solar power satellites become trivial. Asteroid mining pays for itself. Mars colonies? Routine supply runs. Climate engineering? Easy. The first one will be scary. It'll cost a fortune. There'll be endless regulatory whining and equatorial countries fighting over who gets the base. But once it works, game over. Everyone copies the system. This is peak goals are for losers territory. Don't set a goal to go to Mars. Build the system that makes going to Mars as routine as taking an elevator to the 50th floor. As soon as the first one is complete, copies will be everywhere. That's how you win the future. The technology is knocking on the door. Material science is there. What do you think? Would you ride it on day one? Drop your wildest space elevator idea or biggest objection in the comments. If enough of you yell at me, we'll dig deeper into the materials, the politics, or exactly how insane the first deployment day would be.